Hi everyone, welcome to Post UTME class. In today's class, we'll be talking about logarithm. And before we talk about the laws of logarithm, let's look at our learning objective. So in today's lesson, we'll be learning the laws of logarithm, examples of logarithm, and we'll be bringing questions from the past questions. So now, let's look at laws of logarithm. If log b base a is equals to x, then a raised to power x is equals to b. What am I saying? All these a, b, and c and x are just coefficients. Actually, we represent them by numbers. You can use any numbers you like. For instance, now, if b is to be 2, if a is to be 3, and if a is to be 4, then if I have log 2 base 3 is equals to 4, then I will have this one, 3 raised to power 4 is equals to 2. Do you get that? So the second law is that if I have log x base a plus log y base a, if I have this, then I can write it as what? Log xy base what? A. What is the meaning? This plus will actually change to times. Anytime you have addition in logarithm and you have to add them together, you will change it to times. So the third law is if I have log x base a minus log y base a minus, we change to divised. Observe that. So the fourth law, if I have log s raised to power b base a, then the b can come back and I have b log s base a. Or if I have log s base a raised to power b, that means if the base is having a power, then it will now come in reciprocal. What do I mean? I will have 1 over b log x base a. And the last but not the least, if I have log a base b, I can write it as what? 1 over log b base a, or log a base x over log b base x. This last law is called change of base. If you observe, b was the base here, I interchange it, it was now the power here, while a was the base. Then I can also change the base to entire thing. But the implication is that they must have, both numerator and denominator must have the same base. All this law may not really look nice to you, but I'm sure that if I write some examples to the board to illustrate it, I'm sure you are going to get it back. Like I said before, I want to illustrate the laws with these examples now. So I have 5 examples here. Number 1, evaluate log 212401 base 7. Second question says that what if I have log 5 base 2 plus log 1.6 base 2, I'm going to do that also. The third question showed that if I have log 36 base a plus 1 over 2 log 256 base a minus 2 log 48 base a is equals to minus log 4 base a. The fourth question, given that x is equals to 2 raised to power p and y is equals to 4 raised to power q, I should show that log s cubed y base 2 is equals to 3p plus 2q. And the last one but not the least, evaluate log 8 base 4. So I'm going to rub off this side to solve all this using this law. Question number 1, evaluate log 2401 base 7. So I have 2 methods for this question based on the law. So the first method is, if I can represent this one as its index. 7 raised to power 4 is the same thing as what? 2401. 7 times 7 times 7 times 7 will give you 2401. So I have log 7 raised to power 4 base what? 7. Remember in the fourth law I gave you, the laws I listed. So if I have something raised to power, that means the power can come down. Then I have 4 log 7 base 7 is equals to 4 times 1. And that 4 times 1 is 4. And I said, note, if you have log something and it's having log that has the same base is 1. Log 7 base 7 is equals to 1. So that is how I have 1 here, and 1 multiplied by 4 will give me 4. On the other hand, the second method, I can say let the entire thing be equals to x. So I want to apply the first law I gave you. Then this one can come up 7 raised to power x can be equals to 2401. And if you change equal base, can cancel out. X is equals to what? 4. Yeah, given that x is equals to 2 raised to power p and y is equals to 4 raised to power q, show that log s cubed times y base 2 is equals to what? 3p plus 2q. So the first thing I'm going to do here is to write the question given to me back. So they gave me that x is equals to what? 2 raised to power q p and y is equals to 4 raised to power q. And they gave me this to evaluate this. So I will start from the left hand side of the equation. That is why I wrote from the left hand side of the equation. I have this, and I'm going to write what s is representing and what y is representing. So already we are given that x is what? 2 raised to power p. So I have s cubed here. That will be 2 raised to power p times 3. And we have what? 2 raised to power 3p times what? 4. Remember that 4 is equals to what? 2 times 2, which is 2 squared. So I can then write 4 as 2 raised to power 2 times q. So bringing them together, I have 2 raised to power 3p times 2 raised to power what? 2q. From the law of indices, if I have 2 raised to power 3p times 2 raised to power 2q, I can write it as what? 2 raised to power 3p plus 2q. I can then apply law of logarithm now by bringing 3p plus 2q to the back, and I will have what? Log 2 base 2. And you know that log 2 base 2 is what? Is 1. So 1 times 3p plus 2q, this is q, pardon me, this is q, then times 1 will give me 3p plus 2q, and I've gotten the right hand side of the equation. I hope you get that. Who can tell me the law I'm going to use here? Yeah, the second law. So the second law states that if I have plus in between two logs, that means that plus will change to what? Multiplication. Thank you. So I have log base 2 times what? 5 times 1.2, which will give me what? I can convert this one to what? Fraction, right? So if I convert 1.6 to fraction, it will give me 16 over what? Over 10. Thank you very much. So I have log base 2, open bracket, 5 times 16 over 10. I can then reduce the fraction. I have what? 5 counts 5 here 1, 5 here 2, right? I have what? 2 here 1, 2 here 8, right? So the result of everything here will give me what? Log 8 base 2. Then I can then apply another law, right? Which is what? Which law is that? Who can tell me? You can put that in the comment section. So I have what? I'm going to use the what? The fourth law, which states that what? If I have anything, if this one raised to power anything, the power will come to the back, which is what? I have 3 log 2 base 2, and you have to know that anything like this is equals to 1. So I can then write it as what? 3 times 1, which is what? 3. I believe you understand that. So question 3 show that all this one is equals to minus log 4 base a. So this is the question here. I have log 36 base a plus 1 over 2 log 256 base a minus what? 2 log 48 base a. So we want to show everything here to be equals to what? Minus log 4 base a. Are you there? So I have what? The first thing I'm going to do, this one, I can see something here, I can bring it to the back. So which is going to be like this. I will still write everything that was up here. I'm still going to write them here back. So this next thing to do is from the law of indices. I know that if I have 256 raised to power 1 over 2 is the same thing as square root of 256. So our square root of 256 is what? 16. And if you notice, I still retain everything that is up apart from this one. I'm working on this one first, right? So I have 16 here because square root of 256 is 16. So then I apply both the second and the third law of logarithm. Yes. So how do I apply them? Earlier I told you that if I have plus is the same thing as what? Times. If I have minus is the same thing as what? Divide. So I then have log 36 base a plus log 16 base a minus what? Log 48 square base A. The square is coming from these two. If these two return back up, I'm going to have 48, right? 48 square, right? So I then bring everything together using the law, the third and the fourth law. So I have this 36 times 16 over 48 times 48. 48 square is the same thing as what? 48 times 48. I then reduce it to a simplest form. So I have what? Log what? 1 over 4 base A. And I can recall from the law of indices, if I have a raised to power minus n is the same thing as what? 1 over a raised to power what? N. You should know this one before now. It's from log indices. So that is why I can change 1 over 4 to be what? 4 raised to power minus 1. And I apply the fourth law of logarithm to bring the minus 1 back. So I've gotten what they asked me to prove. So my answer is then what? Minus what? Log 4 base A. Is that clear? Yeah, finally, we have gotten to the last question. So, and the last question is evaluate log 8 base 4. Because I know the law, I can use any method that is suitable for me. So, method 1, I can write log 8 base 4 as what? 8 can be represented as what? 2 raised to power 3. And this 4 can be represented as what? 2 raised to power 2. Then, from the fourth law, 3 can come to the back. Then I'm going to have 3 log 2 base 2 raised to power 2. If this one, I don't like to use this one, I can use method 2. I have what? Log 8 base 4. So this second method is what? Change of base. So I can change the base. Instead of 4, I can put 2 or anything you like. Some people may want to put 10. Some people may want to put 11, any number you like. But why I put 2 is because I know that I can represent both 8 and 4 as an index of what? Of 2. That is why I put it there.